Hi guys, a rainy afternoon from Tagaytay City, and welcome to Differential Equations. In the previous lesson, that is lesson 6, we learned that by multiplying an integrating factor to a non-exact equation will make it exact and thus can be solved by exact equations. In today's lesson, we're going to talk about linear differential equations. But first, our gospel thought. The scripture is found in 1 John 4:19 and it says, "We love each other because He loved us first." Believing that God loves us so deeply can be hard. When we mess up and make bad choices, it can be difficult to believe that God cares. When we see all our failures and flaws, we can often think that we're unlovable. However, in the midst of all our failures and shortcomings, God chose to love us anyway. God's love for us should energize us to love other people. When we focus on all God has done for us, it makes loving other people easier. God's love is empowering. It gives us the strength and motivation to truly love others. So when you have those moments when you struggle loving someone who is less than lovable, realize that you've got the power to do it because God loved you first. When you didn't deserve it and were an enemy of God, God loved you. That knowledge gives you what you need to love others. As Lasalians, let us respond and pray. I will continue, O my God, to do all my actions for the love of Thee. Saint John Baptist de La Salle, pray for us. Live Jesus in our hearts forever. In the name of the Father, the Son, and the Holy Spirit. Amen. Alright, first let us proceed by defining what a linear differential equation is. In the past few lessons, we have been looking at different techniques for us to be able to solve differential equations. We continue our quest today for solutions of first-order differential equations by next examining linear equations. Now, linear differential equations are an especially friendly family of differential equations in that given a linear equation where first-order or higher-order kinds, there are always a good possibility in these types of TEs that we can add some sort of solution of the equation that we can examine. So let's take a look at how these linear differential equations are defined. A first-order differential equation of the form a sub 1 of x dy over dx plus a naught or a sub 0 of x multiplied by y is equal to b of x is a linear differential equation where a sub 1 of x, a naught of x, and b of x depend only on the independent variable x and not on y. If we will recall our lesson from lesson 1, wherein we classify differential equations based on their order, based on their degree, based on whether they are partial or ordinary, and if they are linear or nonlinear. We will recall that we are basically basing our definition for linearity on two characteristics. Recall that we consider our number one consideration is we look at the independent variable. If our derivative is dy over dx, our dependent variable. This is our dependent variable. This is our independent variable, right? Still recall? We base on our dependent variable. In this case, that is y. That is our first characteristic. And its order, let's call it n. If n is equal to 1 only, then it is linear. The analogy I gave here is that we look back at our definition of a line. We will recall that a line, well, is defined as y is equal to mx plus b, right? Now, y squared is not a line because it is a parabola. Y cubed, etc., are not lines. In other words, if we have to look for the order of the dependent variable, we must see to it that it is only raised to 1. right? That's the first characteristic. The second characteristic is that the coefficients, let's say a sub 1 of x, of our derivative, dy over dx, should only be dependent on the independent variable. Right? In other words, this is linear, but a sub 1 of y, dy over dx, is not linear. What are some examples? For example, we have y and then y prime, or y and dy over dx. This is not linear. This is non-linear. What else? We have cosine y, dy over dx. This is non-linear because the angle for cosine, which is y, no, is dependent on, well, the angle being used is the dependent variable, no? We defined linearity to be of that the coefficients should be based on the independent variable. So clearly this is not linear. But how about cosine x, dy over dx? This is still linear even if it is cosine, which is not a line, because x here, the angle, is dependent on the independent variable. Alright? So I hope you recall that part, because we're going to look at some or two examples here, no, for us to refresh our memory on the linearity. For example number 1 here, we have x squared sine x minus cosine x times y is equal to sine x multiplied by dy over dx. My question is this a linear or non-linear differential equation? The answer is, this is a linear differential equation. Why? We take a look again at our two characteristics. We first look at our y. This is our y. Of course, the context here is that our derivative is dy over dx, which is this one. Right? We take a look at our y, and we will notice that in our y, it is raised to 1. No? The power is 1. While the coefficient here, cosine, is an expression of x, a function of x, right? So, cosine x will not make it nonlinear because ano naman siya, function siya ng x. Now, x squared here, okay lang dahil nga x naman siya. No? So, basically two characteristics, y and then the coefficients. Okay. Now, next. How about number 2? Is this linear or nonlinear? Is this linear or nonlinear? This is actually not linear. Why? Because if we take a look at our y, it can be clearly seen that this is raised to 3. No? Other than that, eto pa. No? The coefficient of our derivative is not dependent on x. So these two made the equation not linear. It also is not or does not conform to the form of the linear form, which is this one. No? If you transform this to this form, no, you will notice that yun nga, yung y natin is raised to 3. It should only be raised to 1. Okay, let's move forward. Now, how do we solve linear differential equations? How do we solve linear differential equations? There are two situations for which the solution of the said linear differential equation, no, is quite immediate. So, tignan natin yung dalawang situations na yan. Situation 1, okay? When a naught of x is equal to 0, for then the equation reduces to this form. a sub 1 of x dy over dx equals b of x. Ano daw? If this a naught here is equal to 0, so what happens? This cancels out. And so we're left with two terms. This term and this term, which is ito nga. At saka ito. Okay? Now, what can we notice on this form? Assuming na again nga a naught of x is equal to 0. We can notice that itong ating differential equation can be solved by means of variable separable. Paano? Well, we can move a1 of x to the other side. And paano natin gagawin yun? By multiplying 1 over a sub 1 of x. So 1 over a sub 1 of x cancels out on the left-hand side of the equation, and we're left with dy over dx equals b of x all over a sub 1 of x. Now, we can multiply dx on both sides, and so separating the variables, we're gonna get dy equals b of x a sub 1 of x multiplied by dx. Now, this can be solved through integration. Integrating dy, or the left-hand side, and the right-hand side of the equation gives us the solution in terms of y to be the integral of b of x, a sub 1 of x, then dx. And yes, that is our solution for that situation, for linear differential equation. Alright, let me just erase this. I show this to you so that you will understand the flow, how it turned out to be like this. Okay? Yeah. Of course, where a sub 1 of x, this denominator here, is not equal to 0, no? Not equal to 0. Always remember that, because we cannot divide a 0 to both sides. Alright, so let's move forward. What about we consider if a sub 1 of x? What happens if, or a sub 0 of x, no? This a sub 0. What happens if this a sub 0 of x, for situation 2? I'm sorry, I'm having trouble here. Alright, yeah, nakuha na yung laser. So in situation 0 or situation 1, we noticed, or we assumed, that our a sub 0 is equal to 0. And it pretty much made the analysis or finding the solution easier, because it turned the equation to be a separable one. Now, let's take a look at another situation. What's that situation? What if a sub 0 of x equals the derivative of the first function, that is, the derivative of a sub 1 of x? Then the left-hand side of the equation simply comprises of the derivative of the product a sub 1 of x and then y. Ano daw? What if this a naught of x is equal to a sub 1 prime of x multiplied, of course, by y? What if it turned out to be like that? Well, sulat natin, no? We have a sub 1 of x dy over dx plus a sub 1 prime of x times y, okay, equals b of x. What can we notice about this left-hand side here? We'll notice that isn't this just equal to the derivative with respect to x of a sub 1 of x multiplied by y? Right? Why? Because if we expand this, no, by product rule, derivative, no, kung pa-follow natin yung product rule at ating i-differentiate yung unang term, magkakaroon tayo ng a sub 1 of x prime, and then copy yung second term, y, plus, again, product rule, yung second term naman yung i-differentiate natin. So, copyhin natin yung first term, a sub 1 of x, and then derivative ni y is y prime, or dy over dx, which is interestingly similar to this one, right? Yes. So in other words, we can express this left-hand side. We can express this left-hand side as this derivative, d over dx, a sub 1 of x times y, because they are just the same. So let's go ahead and do that, and we will notice something, okay? So yeah, let me just delete this. Dapat pala hindi ko na siya dinidikit kasi isusulat ko din siya. So we have d, the derivative again, sorry about that. The derivative of the first a sub 1 of x multiplied by y. And then let's try to equate it, well, continue by equating it to b of x. Yan. We will notice that this now becomes, again, separable. So by simply moving out dx on this side, multiplying dx on both sides, we're gonna get what? D, derivative of a sub 1 of x multiplied by y multiplied by b of x dx. Right. Now, if we integrate both sides, we integrate this left-hand side and this right-hand side. I'll continue dito sa space na to, ha. Magkakaroon tayo ng by fundamental theory or theorem of calculus, the antiderivative with the derivative cancels out. And now we're left with a sub 1 of x y equals the integral of b of x dx. Okay. Now, simply by expressing this explicitly in terms of y, we have 1 over a sub 1 of x, integral of b of x, then dx. So this, now, ladies and gentlemen, is our solution for situation 2. Okay? We will notice that when we made that assumption, we were able to transform yung ating linear differential equation into somewhat form that can be solved, in this case, by means of variable separable or separation of variables. So let me just erase this and show you what I wrote. Ayan na nga. I again wrote it for you to see the flow of how it was derived. But as you can see here, yun na nga, this expression here, the left-hand side of the equation, is simply also equivalent to this, the product, the derivative by means of product rule, of this given equation above here. And then by, of course, solving it by means of separation of variables, we got now an expression for y, which is our solution. Because what we're trying to do again here, if I may remind you, the purpose of this is to always look for the solution of a differential equation. Right? Okay. Now, one can seldom rewrite a linear differential equation so that it reduces to a form as simple as situation 1. Ibig sabihin, hindi natin kadalasang makikita na a sub 0 is equal to 0. However, the form in situation 2 can be achieved through the multiplication of a linear differential equation by a well-chosen function called mu of x. Recall this from our previous lesson. Such a function mu of x, again, kung nakakalimutan na, is called the integrating factor for that equation. Okay? Alright. Now, the easiest way to see is to see this is first to divide the original equation. Ano yung original equation? Yung a sub 1 of x. Yung a sub 1 of x, we have a sub 1 of x dy over dx plus a naught of x y equals b of x. Ano daw? The easiest way to see this or to see that how the solution is being solved is to divide the original equation by a sub 1 of x. Ito yon, no? And put it into what we call the standard form. So, paano natin gagawin yun? We divide a sub 1 to the whole equation. So, that is a sub 1 of x. A sub 1 of x. So, a sub 1 of x here cancels out. We're left with dy over dx plus a naught of x all over a sub 1 of x y equals b of x all over a sub 1 of x. Okay, now, we can simplify this further. We can call this part and this part as p of x and as q of x. Therefore, we can, another way to express this is by dy over dx plus p of x and then y equals q of x. Yan. And that is what we call our standard form. So, pakisulat muna yan sa inyong mga papel because this is a very important equation. This is the standard form. Okay? Standard form. Okay. So, ito lang din yan. Burahin ko muna. No? Ito yan. dy over dx. Yan. We have p of x and we have q of x. Where, of course, yun nga, p of x, as derived already and showed already earlier, is equal to a naught of x over a sub 1 of x, and q of x equals b of x over a sub 1 of x. Now, next, we wish to determine mu of x. Ano yung mu of x natin? Siya yung ating integrating factor. So that, the left-hand side of the equation, or the left-hand side of the multiplied equation, this part, is just the derivative of the product mu of x times y. Paano? Yun daw derivative ng mu of x times y. Hindi ba't yun ay by product rule, no? Differentiating the first term, magkakaroon tayo ng mu prime of x and then copy si y plus yung second term naman ang di-differentiate natin. So, copy sa first term, mu of x, and then differentiate si second term, which is dy over dx. Ano daw ang sinasabi? We need to find yung ating mu of x. We need to find yung ating mu of x. Oops, sorry. Ito pala. We need to find yung ating mu of x, which is yung ating integrating factor. Para daw saan? Para kapag ka nag-multiply tayo ng mu of x sa whole equation, this one, if we multiply mu of x here, we're gonna get this expanded expression right here sa baba. Now, we will notice again, by applying the same principle that we demonstrated on the previous slides, that the derivative of mu of x and y is simply just the product, the product of this is the left-hand side. Ito. Yan. Bakit? Ano bang ligayang makakamtan natin pagka in-express natin siya sa gantong function, Kagaya nga nung ginawa natin kanina, ang mangyayari sa kanya, magiging variable separable siya. So, ito yon. So, ito nga, mu of p of x. So, magiging equivalent siya sa ganito, itong left-hand side na ito yon. no? Dahil magiging ganito siya, mu of x, y prime plus mu of prime of x, mu prime of x times y, which yung ating pinakita yung ating pinakita kanina. Yun, no? Alright. Now, clearly, this requires that mu of x satisfy mu prime of x. Ito daw yun, no? Para maging makatotohanan si mu of x, para maging totoo ito, no? Maging posibilidad siya. Kailangan alam natin si mu prime of x, no? Kailangan nating ma-solve kung sino si mu prime of x. At kung titingnan natin, ano, pag in-equate natin, hindi ba si mu prime of x ay equal sa mu of x p of x times y, or mu of x p of x? Now, how do we solve this? Paano tayo magkakaroon ng expression for mu of x? That's what we're going to solve in the next slide. So again, nakita natin na important si integrating factor. Now, to find such a function, that mu of x, we recognize that the equation mu of x equals mu of x p of x. Ito nga yun, no, mga kaibigan. Ito po. Yan, ito yun. Is simply equal to this one. Right? Yun. We recognize that mu prime of x equals mu of x p of x, which is, well, a separable differential equation. A separable differential equation, which we can write as, yan. We can write as, hindi ba, mu prime of x is also d mu over dx equals mu of x px. May separation of variables. Pagsamahin lahat si mu, we have d mu over mu of x equals p of x and then dx. Alright. Now, we can solve this by integrating, and we're gonna get ln mu equals integral of p of x dx. Now, if we raise both sides to e to cancel yung ating natural logarithm, we're gonna get mu equals e integral of p of x dx. Ayan, another very important equation that you need to take note of, no? You need to take note. This is our second important equation, which is the integrating factor. So please recall and remember that. Yeah, mu or mu of x equals e to the integral of p of x dx. So ito yun. Yan. Okay? Now next, with this choice of mu for mu of x, we have here, yun na nga yung ating original equation kanina. Diba, the concept of integrating factor is that when we multiply it to our original function, it becomes something else. Right? Naalala pa sa non-exact? Now, it now becomes, in the sense na it becomes something else in the sense that it becomes solvable. Yon. It now becomes, ito nga, this is simply equivalent to the product of mu of x times y, no? Equating it to mu of x q of x. We can now we can now look for the solution, no? And this is now the solution. Yan. Paano ginawa natin yon? Itong dx, we simply multiplied here. Here. Yan. And this became now separable, integrating both sides. No? Yan. Nag-arrive tayo sa ganito. Natanggal si d because anti-differentiating the derivative cancels that. So we have y mu of x equals the integral of this one, which is this, of course, dx, and then huwag natin kakalimutan yung plus c. Now, kung manonotice nyo dun sa integrating factor natin kanina, nung nag-integrate tayo, hindi na tayo nag-plus c. Bakit ganon? Dahil ngayon, nire-represent na natin siya as a single representation. No? So, mga single dyan, no? Yun. Nire-represent kayo sa dulo. Okay? As a single arbitrary function or arbitrary c. Okay? So, dinisregard muna natin siya for simplicity dun sa ating mu of x kanina sa integration natin. Alright. So, this form here, so wag kakalimutan yan ha, this is number 3 important equation, and this is what we call the general solution, GS, to this given differential equation. Yan. So, tatlo, no? We have the standard form, we have the integrating factor, and finally, the general solution. Now, pag nakuha mo lahat ng mga sangkap na yon, maaari mo nang masolve ang mga differential equations na may ganitong form. dy over dx plus p of x equals q of x. Alright. Now, to generalize, here's a recommended method or procedure in solving linear differential equations. 3 simple steps. Number 1, write the equation in standard form. So, standard form. Ito yon. So, kailangan i-transform muna yung equation into that kind of form. Taking note of course, the signs. Siyempre, positive to, positive din to. No. Next, we calculate the integrating factor by the formula mu of x equals e to the integral of p of x dx. Alright, this is important, and we have already derived this already earlier, so hindi ko na of course nilagay kung paano pa siya kinuha. So ito na lang yung kailangan nating i-take note, no? This is our IF, integrating factor. And finally, the third step, we apply the general solution, and that is y mu of x. Again, na-derive na ito, no? Kanina. And it's up to you if you want to memorize or take note of it. Pwede mo rin namang i-differentiate or i-derive, no, from the given equation. But basically, if you see a differential equation that has this form, makakaasa tayo na meron siyang ganitong solution. Ganitong solution. Alright? Okay. So, let us now proceed with some sample problems, no, for us to be able to appreciate solving linear differential equations. Let's go to our first example. Okay. So we have here dy over dx plus 5y equals 50. Let's solve this. Okay. So, what's our first step? No? Our first step is to take a look at the equation if it is in standard form. And what is our standard form? Tama. dy over dx plus p of x y equals q of x. Okay. Now, let's compare by simple visual inspection from our equation, given equation, dy over dx plus 5y equals 50. We can easily notice that p of x is equal to 5 and q of x is equal to 50. No? So now that we have those forms or those equivalences, we can now proceed to our next step, which is getting the integrating factor. You are correct. So we have mu of x equals e to the integral of p of x dx. In this case, we have mu of x equals e, the integral of 5. So, pwede ko ilabas si 5. Integral of, sige, ilagay ko na rin para hindi nalilito. This is simply 5, then dx. Okay? Right? Since constant siya, I can factor it out. I will get 5 integral of dx. And of course, we can now get our mu of x, and that is e raised to 5x. Now, disregarding again yung ating plus c. So, please do take note of that. So, we have mu of x and then p of x. Of course, we now move on to our third step, which is getting the general solution. And what is our general solution? That's y mu of x equals integral of mu of x q of x dx plus c. All right. So plugging in all our values that we have already computed, and we have y, and then we have e to the 5x equals the integral of e to the 5x q of x, which is 50, no? And of course dx plus c. Okay. So solving, integrating this first, no? We have, I can factor out 50, integrate e raised to 5x dx plus c. I'm going to get 50. The integral of e raised to 5x. Now, if u is equal to 5x, then du is equal to 5 dx. In other words, I need to insert 5, no, to my integral. So, magkakaroon ako ng e raised to 5x all over 5 plus c. Okay? So, we can divide 50 and 5, and we'll get 10 e raised to 5x plus c. And then, of course, syempre, copying to y e raised to 5x. If we divide e raised to 5x on both sides, magkakaroon tayo ng ano? Move ko lang to. We're gonna get y. We're going to get y equals, yan, e to the 5x cancels out, so 10 na lang matitira dito, plus c, then e raised to negative 5x. And there we have it. Ladies and gentlemen, our final answer. Okay. Let's now move on to our next example. So we have di over dt plus 10I over 2t plus 50 equals 10. Now in this problem, we have a given condition, and that is I at t is equal to 0 is equal to 0. Let's solve that. Solution. Again, our first step is to what? Recognize the standard form, and that is dy over dx plus p of x multiplied by y equals q of x. Okay. Taking a look at it, the problem, that is, it has a different variable, no? It uses I and t. So we have di over dt plus p of t, and then I, which is our dependent variable, equals q of t. By simply looking at it and inspecting it, we'll notice that p of t is equal to what? 10 over 2t plus 50. 10 all over 2t plus 50. Also, we can notice that q of t is easily recognizable as 10. Yun. Ngayon na nakuha na natin yung mga mahalagang sangkap gaya ng p of t, which is important, we can now move forward in getting the integrating factor. And that is mu of x equals e to the integral of, ayun na, oh, p of x. I'm sorry, we're using t nga pala. Yan, minsan nakakalimutan lang. P of t, P of t, or mu of t, P of t. Yan. So, substituting our values, we'll have mu of t equals integral of e, integral of what? Ayun, 10 2t plus 50 all over 10 and of course dt. Or sige, lagyan na natin dito. Parang hindi tayo nalilito. Okay, now we can simplify this further. We have mu of t equals what? We can factor out 10 e raised to the integral of, I can factor out 10 and I'm left with 2t plus 50 all over dt. Ayan, all over dt. Now simplifying this further, how do we integrate this given function here? dt over 2t plus 50. We can actually let u be equal to 2t plus 50 and get du equals 2 dt. In other words, I need to insert 5, or 2 rather. I need to divide 10 by 2. So magkakaroon ako ng 10 over 2 integral of du over u. Of course, this is e raised to. Yan. Okay. And we know that this is going to be e raised to 5 multiplied by ln u, which is 2t plus 50. Yan. Alright. Now, by properties of logarithms from our high school algebra, this becomes, yung 5 here could be an exponent to this function. So this will become ln raised to, or ln 2t plus 50 raised to 5. Yan. And we know that when the natural logarithm is raised to e, it now cancels out and becomes mu of t becomes 2t plus 50 raised to 5. Yan. So, meron na tayo ng ating mu. Okay. We move forward to our final stage, and that is in getting the general solution. That's right. Which has the form of, in this case, we're using the variable I and t. So, we have I, and then mu of t equals integral of q of t, or sorry, mu of t, q of t, dt, and then plus, of course, c. Okay. So, we have I. Our mu of t is 2t plus 50. 2t plus 50 raised to 5 equals the integral of the same, which is 2t plus 50, again raised to 5, multiplied by qt, which is, yun, wow, qt naman ito, 10 plus c. Okay, sorry, ako na lang tumatawa sa sarili kong joke kasi wala namang ibang tatawa sa akin, di ba? Yun. So, if we integrate this, we're gonna get, we can actually factor out 10, no? Then integrate 2t plus 50. We know that 2t plus 50 is, by power rule, 2t plus 50 over, multiplied, I'm sorry, the power of 6 over 6. Pero dahil meron tayong u du, no? If we let u to be 2t plus 50, du will become 2t dt. So, we need to insert 2, right? Naalala pa. Sorry, hindi ko na ipapakita rito dahil I assume that from your integral calculus, that's already a standard, or that assume that you know it already. So 2t plus 50 raised to 6 all over 6. Yan. And then, of course, plus c. Okay. So, further simplifying this, we're going to get 10 over 2 is 5. And then 6, we have 5 over 6. Yan. And 2t plus 50 raised to 6 plus c. Okay. Baba natin to. Kakaroon ako ng I. Then 2t plus 50 raised to 5. Now, I can divide 2t plus 50 here to both sides para singular expression or explicit expression na lang siya in terms of I. And we're going to get what? We're gonna get I equals 5 over 6 multiplied by 2t plus 50. Bakit 2t plus 50 na lang yung natira? Kasi di ba, ito, this is 6 and this is 5. So 6 minus 5 is 1. Kaya, ang natira na lang dito, 2t plus 50. Pero, pagdating dito, sa c, kasi we divided it to the whole equation, 2t plus 50 becomes raised to negative 5 now. Yan. Now, tapos na ba tayo? Hindi pa. Kasi, kailangan pa nating i-apply yung ating condition. And that is at I 0. I is 0 when, of course, we know this to be t. I is 0 when t is equal to 0. Now, we apply this condition for us to solve for, yes, c. So, let's go ahead and do that. We have 0 equals 5 over 6. And then 2t plus 50. That will be 2 times 0 plus 50 plus c. 2 multiplied by 0 plus 50 raised to negative 5. This now becomes, of course, this is 0. And this is 0. So I am left with 5 over 6 multiplied by 50 plus c multiplied by 50 raised to negative 5. That is my, well, O equal to 0. Kasi we're trying to solve for c. Okay. So what is c? You can solve for c. We have c 50 raised to negative 5 equals negative 5 over 6 times 50. Tama? Nilipat lang natin tong 5 over 6 to the other side. Magkakaroon tayo ng, if I divide 50 raised to negative 5 on both sides, I'll have c equals negative 5 over 6 multiplied by, since same naman sila ng base, parehas silang 50, this now becomes 6. How? Kasi di ba ito ay negative? So kapag ka ito ay dinivide ko, magiging positive siya. Mapupunta siya rito. 50 raised to 5 times 50. So that will be 50 raised to 5 plus 1. Kasi same sila ng, naalala pa, because a raised to n multiplied by a raised to m becomes a raised to n plus m. So by properties of powers, no, from our elementary algebra, high school algebra, no? And so yan, we have now an expression for c, and that is negative 5 over 6 times 50 raised to 6. Okay? Now, we plug it back into our original equation. The particular solution now is now I equals 5 over 6. Okay. 5 over 6 multiplied by 2t plus 50 plus yung c na nakuha natin, that's negative 5 over 6 multiplied by 50 raised to 6. Of course, multiplied again. 2t plus 50. 2t plus 50 raised to negative 5. Ayan. And there we go. There we have it, ladies and gentlemen. Our final answer. Okay? Alright. Okay lang? Sige. Let's move forward to another example. That is example number 3. So, solving this, we have dy over 4dx plus 3y over x equals x squared. Again, we will notice that this is a linear differential equation. How? Kasi let's take a look at our y. It's raised to 1. Characteristic ng how an equation or a DE is linear. We look at y first. Is it linear? Is it raised to 1? Yes. Again, next, we look at dy over dx and its coefficients. Are they all in terms of x? Well, in our case, in example number 3, yes. So this is a linear differential equation. Okay. So how do we know if a differential equation is linear, exact, variable separable, homogeneous? We simply look at its form and then we try and figure out if the solution we think is the best solution for it. Okay? So, in this problem, this is clearly a linear differential equation. How do we solve this? We first take the standard form, and that is dy over dx plus p of x y equals q of x. By visual inspection, we'll notice na merong 1/4 dito. So we need to multiply 4 to the whole equation to cancel out that negative or that 1/4 para makakomply tayo sa standard form. And that is, dapat dy over dx lang siya. Wala siyang ibang katabi. And so, if you multiply 4, we'll get dy over dx plus 4 times 3 is 12, right? 12 over x multiplied by y equals 4x squared. Yan. Looking at it, we can now identify what p of x is, and that is 12 over x, right? 12 over x. Next, we have q of x, and that is simply for x squared. Alright, now we proceed with getting the integrating factor, and that is mu of x equals e integral of p of x dx. Now we can clearly see that px here, or p of x, is 12 over x. In other words, we have mu of x equals e to the integral of 12 over x dx. This is also equivalent to, we can factor out 12 integral of dx over x. This gives us e to the 12 ln x. Okay. Now, we can simplify this further, noting that by properties of logarithms, we have e raised to ln x raised to 12. Okay. And we know that when a natural logarithm is raised to e, they cancel out. So we get mu of x equals simply x raised to 12. Ayun. Okay. We proceed to our next step, which is finding the general solution. And that is, move lang natin na kaunti. No? And that is y mu of x equals the integral of mu of x q of x dx plus c. Yun. So we have y. Plugging in all our values, we have y. And then mu of x is x to the 12. So x raised to 12 equals the integral of x raised to 12. And our q of x is what? Our q of x is, nakuha na natin kanina, balikan lang natin. We have 4x squared. So we have 4x squared dx and then plus c. Okay. So, integrating, we can factor out 4 because it's a constant. Magkakaroon tayo ng x raised to 14. Right? Because we multiply, well, we add the powers of the exponents. 12 plus 2 is 14. Dx, of course, and then plus c. Integrating this will give us 4 and then x raised to 15 all over 15. Right? Plus c. Copying, of course, yung ating y, x raised to 12. Now we can further simplify this, and it can become, this will become, if we divide x 12 no, to both sides of the equation, that is multiplying 1 over x raised to 12, makakaroon tayo ng expression that is y equals what? 4 over 15 multiplied by 15 minus 12 is 3. So that will be x cubed plus c x raised to negative 12. Yan. And yan. There we have it. Our final answer. Y is equal to 4 over 15 x cubed plus c x raised to negative 12. Okay. Let's proceed to our next problem. We have, yeah, this is kind of an exciting problem. Let's take a look. At example number 4, we have LDA over dt plus Ri is equal to E with conditions I at t is equal to 0 is equal to I naught or I sub 0. Excuse me. So, this is a basic equation, no? For ECEs and electrical. This is an equation that consists of L as an inductor, I as the current, and R as the resistor, where E is the voltage source. Okay? So, this is an expression of a simple electric circuit, and we can actually solve for, well, the current given these situations. Okay? We will explore on this further on our coming lessons on actually applying differential equations on real-world problems. All right, so let's go ahead and solve this. So again, we first recognize the standard form, and that is dy over dx plus p of x y equals u of x. Okay? Looking at it, hindi pa siya naka-express into this form, dy over dx plus p of x y equals q of x. So we need to transform it, well, to conform to this standard form. And we can do that by multiplying 1 over L to the whole equation para mawala yung L sa taas, sa di over dt. Right? Ang variable nga pala, or variables na ginamit ay I and t. So this should be di over dt plus p of t equals q of t. Alright. So, if we divide L to the whole equation, we're gonna get di over dt plus r over L I, nakalimutan ko lang natin yung I dito, equals E over L. Ayan. So from the looks of it, we can identify by simple inspection that P of T is actually equal to R over L, and that Q of T is actually equal to E over L. Ayan. So we can proceed to our next step, and that is by identifying what is the integrating factor. Integrating factor is composed of mu of x equals e raised to the integral of p of x dx. So, na-identify na natin si p of x. Ito yon. That's r over L. So, plugging in our values, we're gonna get mu of x equals e to the integral of r over L. Of course, multiplied by dt actually, dt. Not dx. Lagi ko siyang nakakalimutan. Yan. And then t. Okay. Alright. Para consistent yung ating notations. Now, this is also equivalent to what? E raised to. Now, dun sa ating given na example, yes, it was indicated that L, R, and E, and I not are constants. So R and L here are constants. In other words, we can factor this out. R over L, and we're left with the integral of dt. Yan. So, integrating dt, we'll get R over L times t. Okay? And that's our integrating factor mu of t. Okay. So, we proceed with getting the general solution. So, the general solution is what? It has the form of I yung variable natin, yung ating dependent variable, I, and then mu of t equals integral of mu of t q of t dt, of course, never forget, plus c. So, plugging in all our values, we'll get I multiplied by our integrating factor, that is e raised to r over L times t. Okay? Equals integral of excuse me, the same, e raised to r over L times t, the q of t, which is e over L, diba? dt And of course, plus C. Ayun. So integrating, we'll get, since E and L are constants, we can factor that out. We have E over L, integral of E raised to R over L T, right? And then dt plus C. Now integrating this function, EU du, no? But if we let U to be RL, so if we let U to be R over L, and ito ay constant, so magkakaroon tayo ng du equals R over L dt, right? Yun. Or R over L t. So in other words, we need to insert L over R, no? O yung inverse nito sa ating function as we integrate it, kasi meron tayong insertion factor, no? Para makakuha ng equivalent expression for dt. So, we're going to get E over L equals L over R E raised to R over L T. Yan. Okay. So, move ko lang to dito, okay? Para hindi sa gabal, no? Okay. So, yan. Meron tayong expression here. Of course, plus C. Now, it can be clearly noticed that L cancels here, no? And we're going to get, move natin dito. We're going to get E over R. E over R. E raised to R over L. Oops, move na lang uli natin dito. Para may space pa tayo later on. Okay. E over R over L. And then T plus C. No. That is our right-hand side. Of course, copying, we have I E raised to R over L and then T. Now, if we divide, no, the whole equation by 1 over E raised to R over L T, we can eliminate, no, yung ating E raised to R over LT on the left-hand side, in this side. Okay. So, magkakaroon tayo ng expression for I, and that is I equals E over R. Yan. Mapapansin natin, this cancels out. We're left with plus C, and then E raised to negative R over L D. Okay. So that is our expression for I. Now, are we finished? We're not yet finished because we need to apply our condition. What is our condition? The condition is at I of 0 is equal to I naught, or I sub 0. And then, using this condition, we'll now be able to solve for C. So, doing so will give us I will be equal to 0, or I naught, no? I naught equals E over R plus C, which is the one we're looking for, and then when T thou, this is T, right, is equal to 0, we're gonna get E raised to negative R over L times 0. But E raised to 0 is equal to 1. Pwede nyo po ma-verify yan sa calculus nyo. So, pag nakalimutan nyo, calculus nyo lang. E raised to 0. That is equal to 1. In other words, we're gonna get C, no? Solving for C, magkakaroon tayo ng I naught minus E over r. So finally, substituting our values to this equation here, we're gonna get c, or rather I. So particular solution, we're gonna get I equals E over R plus C. But C is, yun nga, I not E over R. So I not minus E over R. Or, ano palitan? Pasok ko na lang. I not minus E over R. And then, of course, multiplied by E raised to negative R over L times T. And yes, there you have it, ladies and gentlemen, our solution. Particular solution, that is for our differential equation. Yan. Ayan. I equals E over R plus I naught minus E over R multiplied by E raised to negative R over L times T. Okay. Let's now proceed to our next problem. Example number 5. So we have here another problem. X raised to negative 1 dy over dx minus 2y over x squared equals x cosine x. So let's solve this. And we'll get a solution. We'll get, of course, again, our first step, recognizing or conforming to the standard form. And that is dy over dx plus p of x y equals q of x. From the looks of it, hindi pa siya nakaganong form, so we need to conform. So, how do we do that? Well, we multiply x. Multiplying x to the whole equation, we'll get dy over dx what? Minus, we have 2 over x. Yes. And then y equals cosine x. Because na-eliminate na yung x. We divided, well, actually, we multiplied. So this should be x squared pala. Right, yes. X squared cosine x. Ayan. Okay. So, we can now proceed with identifying what p of x is. From the looks of it, by simple inspection, we can see that p of x here is equal to negative 2 over x. Sir, bakit negative? Kasi, yung original sign is plus. Okay? So, we need to include yung negative sign. Kasi this is also equivalent to dy over dx plus negative yun 2 over x and then y. That's why we included 2 over x, or sorry, negative 2 over x dito sa ating p of x. Okay? So I hope that is clear. That is why ginagawa natin lagi itong standard form na ito para strategic and or madaling makita kaagad what is p of x and what is q of x. Okay? So, we proceed with identifying what q of x is. And by simply inspecting, that is simply just x squared cosine x. Ayan. So, we proceed with computing for the integrating factor. And that is mu of x equals e raised to the integral of p of x, then dx. Okay. We have mu of x equals e raised to the integral of p of x. That is negative 2 over x dx, which is also equivalent to, by factoring out negative 2, we have e raised to negative 2 integral of dx over x, which is a familiar form, dx over x, we know, which is ln, right? So we have e raised to negative 2 ln x, right? And by properties of logarithms again, we know that we can move this negative 2 as a power of x here. So we'll get e raised to ln x negative 2. Yan. Now, a natural logarithm raised in e cancels out. So we have finally mu of x equals simply x raised to negative 2. Ayun. P of x and then mu of x. We can now proceed in solving our general solution. And that is the general solution being y mu of x equals e raised to the integral, the integral of integral of mu of x q of x dx, at wag kakalimutan ang plus c. So, y, what is mu of x? That's x raised to negative 2 equals integral of x raised to negative 2. Ano yung q of x natin? Kalimutan ko na. Our q of x is x squared cosine x. X squared cosine x. So, we have x squared cosine x. And then, dx. Not forgetting plus c. You can easily note and see that x squared here cancels out. No? Negative 2 plus 2 is 0. And we have y x raised to negative 2 here equals the integral of cosine x dx plus c. Of course, the integral of cosine as we know it is simply sine x dx. Wala nang dx, tapos na eh. Plus c. Y x raised to negative 2. And finally, an expression for y explicitly equals x squared sine x, x squared sine x, x squared quantity sine x plus c. Yan. And there we have it, ladies and gentlemen. Our final answer. We have y equals x squared quantity sine x plus c. I hope you're following. So please do take note of this. Okay. Okay pa? Okay lang tayo? So let's move on to our next example. Alright, we have y prime minus y minus sine x is equal to 0. Now, let's solve this. Solution. Y prime minus y minus sine x is equal to 0. By looking at it, first, we need to, in order to identify if a DE is linear, exact, or what, you need to assess first by simply, inspecting if the equation is or falls on those particular categories. So, excuse me. On this note, if this is y prime minus y minus sine x, we can simply, we know y prime as dy over dx, right? So dy over dx, this equation is also equivalent to dy over dx. Angat natin para may space. Dy over dx dy over dx minus y minus sine x equals 0. No. From the looks of it, well, una, we consider this is linear and see already right away. Why? Kasi naka-dy over dx na siya. Minus y and then minus sine x. We can actually, this is a v of x form, no? We can transpose it on the other side. So meron tayong dy over dx minus y equals sine of x. Okay? Okay, correction. This should be plus pala. Plus. So dy over dx plus y equals sine of x. Okay. Now, from the looks of it, we can now identify. So this is already in standard form, no? This is in standard form. Okay. We can now identify, no, yung p of x natin. Because our standard form is dy over dx plus p of xy is equal to q of x, correct? So p of x here is actually equal to 1. No? Yun yung coefficient ng y. And q of x is equal to yun, sine x. Alright. Now we can proceed to our next step, and that is finding the integrating factor. And our integrating factor mu of x is e raised to the integral of p of x then dx. So solving for mu, dahil meron na tayong mu p of x which is 1, no? This now becomes elementary. E raised to the integral of, since p of x is 1, no, we can factor out that 1 here. We have dx. So we have, in other words, mu of x simply equal to e to the x. Ayan. Alright. Let's now proceed to the next step, which is in finding the general solution. The general solution, C, is defined as y mu of x equals the integral of mu of x q of x dx plus c. Ayan. So how do we solve this one? We have y mu of x as e to the x. So simply, yes, y e to the x equals integral of e to the x, and then yung q of x natin is si sine x. Sine x, and then dx plus c. Ayan. Okay. Now, we're now left to integrate this. Ito nasa loob natin, ano? How do we integrate this function? We have e to the x sine x. From the looks of it, we can only integrate this by integration by parts. And that is taking the integral u dv equals uv minus v du. Okay. So, by integral by parts, integration by parts rather, by IBP, let's use some space here. So by IBP, or medyo taasan pa natin here, yan. By IBP. By IBP, we have the integral of e to the x sine x equals uv minus v du, right? uv minus v du. Now, let u be equal to, how do we prioritize in choosing u from this? Naalala pa? We use Liate, no, to choose a good criteria in choosing u. No? Naks, ikaw ang pinili, no? In choosing u is through this acrostic Liate. Ano yun? Priority natin is from left to right. L stands for logarithmic. I, inverse trigonometric. A is algebraic. T is trigonometric. And E is exponential. Okay. So, we have here two terms or functions. We have two functions. We have e to the x, tsaka meron tayong sine x. Okay? Now, from our criteria, ang unahin natin is, since nauna si algebraic kaysa kay exponential, least priority si exponential actually. So, uunahin natin si sine x. And that is, let u be equal to sine x, whereas du equals cosine x. And of course, v be equal to, or dv equals e to the x dx. E to the x dx. Whereas v, by integrating dv, no, both sides, eu du is simply e to the x. Okay, so substituting, meron tayong bringing this down here, e to the x sine x equals uv minus v du will give me e to the x sine x minus v du, which is this part, v and then du. Integral of e to the x cosine x, of course, dx. Alright. From the looks of it, mukhang hindi natin to kayang i-integrate uli ng simple lang. So, we need to do again, what? Integration by parts. So, from the looks of it, we need to do again another IBP. How are we going to do that? So, by second IBP, we let u be equal to what? Cosine? Yes. And dv be equal to e to the x dx. So, the derivative of cosine is, yes, sine, negative sine x dx. Whereas v is equal to e to the x still dx. Yan. So, defining yung ating IBP, this part here is equal to, so the integral of e to the x cosine x dx is actually equivalent to uv minus v du again is e to the x, or that's negative, no? Negative, no, positive pala, uv. So, e to the x cosine x minus v du, no? v du, so this v and then this u. So since negative siya, negative will become positive. Integral of e to the x sine x dx. Naku, paano na yan? Mukhang walang katapusan itong ating integration by parts, no? Pero if you're going to take a look at it, if we are going to expand this, no? Kasi meron tayong expression e to the x sine x dx, which is, interestingly, is just the same expression as our original, this one. Yun. So, ibig sabihin, maybe we can transpose this e to the x sine x dx back here, no? And get an expression that is equivalent to the e to the x sine x. So let's do that. Expand muna natin ito, no? Expand natin tong buo. Makakuha tayo ng copy natin. Sige, ito muna. So, e to the x sine x, copyin ko na lang dito. Yan. Let me copy this. Lagay natin dito sa kabila. We're gonna get yan. So, kita ba? Nakita naman. Now, nag-solve na tayo kanina ng e to the x cosine x dx. At ito ngayon, so plugging in these values here, plugging these whole values here, papunta rito, right? We're actually going to get integral of e to the x sine x, of course dx, limutan na lang yung dx dito, is equal to e to the x sine x minus, at eto ngayon, papasok natin to dito, yung e to the x cosine x, itong buong to. So, e to the x cosine x plus integral of e to the x sine x dx. Yan. Pasok na natin siya ngayon. But, if we distribute this, magkakaroon tayo ng e to the x sine x minus e to the x cosine x minus integral of e to the x sine x dx. In other words, if we transpose this whole, no, integral here, which is similar dun sa given natin, no, to the other side, papunta rito sa kabila, magkakaroon tayo ng 2 integral of e to the x sine x dx. Kasi parehas naman sila. So, parang 1 plus 1, 2. And we'll have an expression. Pwede natin i-factor out si e to the x, no? E to the x sine x minus cosine x. Ayan. So, mas maliwanag na tayong expression. So, expanding this further will give us actually, taas ko lang ng kaunti, no? Expanding this further will give us integral of e to the x sine x dx equals, if I divide this whole equation by 2, magkakaroon ako ng e to the x over 2 multiplied by sine x cosine or minus cosine x. Ayun, may expression na ako. May expression na tayo ngayon ng integral of ex sine x dx. At yun ay itong equation na ito. Yan. So, ibig sabihin, we can go back to our equation later on and then substitute this value. Itong whole value na ito. Yan. Yan. Okay. Alright. So, e to the x over 2 times sine x minus cosine x. So, let's plug that back to our equation. Sa C, ito yon. Okay. So, magkakaroon tayo ng ito sa ating yan, general solution. So, plugging back that in, magkakaroon ako ng integral of e to the x sine x is e to the x over 2 sine x minus cosine x. Of course, plus c. Ayan. So, of course, bring down y e to the x. If I want to express this in terms of y only, explicitly, magkakaroon ako ng sine, or 1/2 sine x minus cosine x plus c e raised to negative x. Ayan. And there we have it, ladies and gentlemen, our solution for our particular, our general solution. Ayan. So, anong ginawa natin to summarize it all? We did twice integration by parts kasi nga, repeating yung sagot, no? Nagiging repeating yung sagot. So, ang una natin ginawa, this expression, e to the x sine x, integration by parts. So, ito yun. E to the x sine x, uv minus v du. Nakakuha tayo ng this expression. But as we have noticed, this integral here is also, or can be solved by means of integration by parts pa din. Kasi wala namang ibang identity na po pwede rito. So, by doing integration by parts, we have arrived at an expression wherein yung isang expression niya here, which is yung v du, no, is similar to our original expression. Ito. So, plugging this value back here, ito yon, no, plugging it back here, and expanding the equation further, nakakuha tayo ng expression for e to the x sine x dx. Yun. So, pinlag natin dito, ito yun, yung values. Then, we transpose it here. So, since dalawang e to the x sine x dx ang meron, so, nag-add silang dalawa. Ito yun. And then, of course, dividing it to 2 para meron lang single expression for e to the x, or the integral of e to the x sine x dx. Yun. So, we got this expression. And then, this expression was plugged in back dito sa ating general solution. And now, we have an expression for y. All right. So, example number 7. So, we have example number 7, dy over d theta equals secant theta plus y tangent theta with the condition of y at 0 is equal to 1. So, let's try and solve this one. We have solution. Okay. First, we need to recognize kung siya ay nasa standard form na. Ang standard form natin ay dy over dx plus p of x y equals q of x. Okay. You can understand na hindi y and x ang variables na ginamit, kundi y and theta. So, this will be dy over d theta plus p of theta y equals q of theta. Okay. Now, we can see na hindi pa siya nasa standard form ng linear DE, and we can notice na linear differential equation siya kaagad, no? Because it has the form dy over d theta plus p of theta y equals q of theta. So, let us rearrange some terms and we'll arrive with, so rearranging, we'll get dy over d theta minus or plus negative tangent theta y equals secant theta. Okay. From here, we can identify clearly that p of theta is equal to negative tangent theta. And that q of theta is simply secant theta. All right. Now we proceed to our next step, which is in getting the integrating factor, which is mu of x equals e to the integral of p of x dx, where of course we know p of x to be tangent theta. So let's go ahead and plug that in, and we'll have an expression equivalent of, theta pala. Then p of theta d theta. That is equal to e raised to the integral of negative tangent theta d theta. Okay? Now, this tangent theta d theta, how do we integrate tangent? So kung hindi memorized yung tangent, what we can do is we can let u. We recognize that this is also equivalent to integral of sine theta over cosine theta. Tama? Yan. From our Sokatoa. Yan. We can actually let u be equal to cosine theta, right? And du equal to derivative ng cosine is obviously negative sine theta. Okay, of course d theta. So, we'll have an equivalent expression of e raised to, magiging positive itong negative dahil may insertion factor na negative din. So, magkakaroon tayo ng integral ng du over u. And we know that the integral of du over u is ln u. So, e raised to ln u, but u is equal to cosine theta. Okay? I'm sorry, hindi pala. Mali pala ako. Ang nabaligtad ko pala, ang derivative pala ng cosine, yung negative sign. Pero yung integral, hindi, tama. Kasi we're doing differentiation here. Teka, tama nga ba? Wait, let me check. Hindi, yes, tama nga. Cosine theta. Cosine theta. Kasi derivative ng cosine and negative sine theta. Yeah. So, very elementary. And that is equivalent to, so magkakaroon tayo dito ng ln cancels out dahil when ln is raised to e, the natural logarithm, no? So we're gonna get mu of theta equals cosine theta. Yan. So meron na tayong ln. Meron na tayong cosine theta, yung ating integrating factor. Now that we have this very important ingredient, we can now proceed to, yes, getting the general solution. That is general solution having the form y, yes, y mu of theta equals integral of mu of theta q of theta d theta plus c. Ayan. Now, we can plug our values in and we'll get, well, y we have y, and then mu of theta is cosine theta. Cosine theta equals integral of cosine theta, and then q of theta is what? Yung q of theta natin is secant theta. Yan, secant theta. So we have secant theta d theta plus c. Okay. But we know that secant theta is also 1 over cosine theta. So actually, kapag ka-integrate natin to, this cancels out, no? Actually, kahit hindi muna natin ilagay. We know that cosine theta is secant theta. Sige, lagay ko na rin. Kakaroon tayo ng cosine theta is equivalent to 1 over cosine theta. Yung secant theta natin, yan yung equivalent niya. Of course, plus c. It is easily noticeable that this cancels out, no? And we are actually left with integral of d theta plus c, and then y cosine theta. And of course, we know that the integral of d theta is simply theta plus c, and then y cosine theta. Now, we're not yet finished because we need to apply yung ating condition. And that is, at y is equal to 1 when theta is equal to 0, right? So, of course, we apply the condition to solve for the value of c so that we could arrive at the particular solution. So, applying. So, from y cosine theta equals theta plus c. No? We have y is equal to 1 daw. 1. And then cosine theta, cosine, which is 0, equals 0 plus c, right? Yeah. We know that cosine 0 is equivalent to 1, no? Cosine 0 is 1. So 1 times 1 is 1. So we'll get 1 equals c. Yun. So c is equal to 1 pala. Now, plugging back yung ating value for c, now that we have it, for our particular solution, meron tayong y, we can actually express this as y, equals, dividing the whole equation will give us theta secant theta plus 1. Ayun. So, there you have it, ladies and gentlemen. Our solution for this particular solution for this differential equation. Okay? Okay lang, guys? Nakakasunod? Alright. You can rewind this kung meron kayong na-miss na step. Moving on to the next problem. We have, which is actually our last problem. We have x minus 2 dy over dx plus 3x minus 1 over x plus 1 times y is equal to 1. Now, clearly, this is not yet in the standard form. But it is easily noticeable na siya ay linear differential equation dahil, ayan, meron siyang f of x katabi ng y, and then yung dy over dx natin is also an expression of x, and yung y is of the order 1. So, linear siya. Okay? So, we can apply linear DE to this solution. Step 1 is to see to it na naka-standard form tayo, and that is dy over dx plus p of x, y equals q of x. Okay? So, hindi pa siya nakaganyang form, and we need to convert it, transform it, to conform with the standard form. So, if we divide x minus 2 to the whole equation, we're going to get, well, dy over dx dividing x minus 2, we're gonna get dy over dx plus, yan, 3 x minus 1 all over x minus 2 multiplied by x plus 1. And then y equals 1 over x minus 2. Now, from this, we can notice visibly and identify that p of x is actually equal to ayun, x minus 2, x plus 1. Over, or the numerator being 3x minus 1. And of course, q of x equals 1 over x minus 2. Let's proceed by looking for the integrating factor. And that is mu of x equals e raised to the integral of p of x, then dx. Identify na natin si p of x kanina, and this is that p of x. And so, plugging in our values, we're going to get mu of x equals e raised to, ayun, labas ko si 3, no? Kakaroon tayo ng integral of x minus 2, then x plus 1, with numerator x minus 1. Of course, dx. Now, how do we integrate this function here? Pag nag-UDU tayo, parang hindi po pwede. Because if u is, let's say, x plus 1, du mo magiging dx nga. Kaso, x minus 1 naman yung numerator mo, so hindi po pwede. How about trigonometric identities? Meron bang, if you expand this, parang wala naman. Kasi usually, a squared minus u squared. Mga ganun yung form ng trigonometric identities. So, the next thing we need to do is to do. You take a look at this, no? This is actually a fraction, no? So, we can decompose this. And that is through the technique called partial fraction decomposition. So, by partial fraction decomposition, by PFD, we actually want to get or to express c x minus 1. We have x minus 1 all over x minus 2, then x plus 1. Yeah. You can actually express this or decompose this into 2, no, which is a, let's call that a, x minus 2, plus b all over x plus 1, no? And we can get an expression here, no, by taking the least common denominator. And the least common denominator is x minus 2, and then x plus 1, right? And by taking the LCD, we can multiply that LCD to our whole equation dito, no? Yan. And by multiplying that least common denominator, we'll arrive at an expression that is x minus 1 equals a multiplied by x plus 1 plus b multiplied by x minus 2. Ayun. Okay. Now, I can expand this, and this will be a x plus a plus b x minus 2b. So what happens here? We can actually solve this equation. We have two equations, we'll have two equations and two unknowns. So segregating, for, let's get an expression for x, combining all x's. For x, okay. So, ang x natin here is actually here, x and then ax. So, ang gagawin lang natin, pagsasama-samahin natin lahat ng mga may similar terms. In this case, yung x natin. So, we'll have x equals a sub x plus b times x pala. Now, you can notice na x can actually be cancelled here, no? Yan. We'll arrive at an equation that is a or 1 equals a plus b. Let's call this equation 1. Okay? Next. Now, again, grouping similar terms for the constant. Constant natin. Ang constant natin dito ay sina ito, 1, then a, and then negative 2b. So, pag samasamahin sila, kakaroon tayo ng negative 1 equals a minus 2b. Okay? Let's call this equation 2. Now, from our algebra, no, we have two equations, two unknowns. We can actually solve this through many ways. But my preferred way of solving this is the easiest way. And that easiest way is actually by using our calculator. So, by using our calculator, lagay ko dito, no? Labas ko lang yung calculator. Yan. Okay. So, by using our calculator, oops, sorry about that. By mode 5.1, by, actually kahit dito ko na ilagay, no, sa baba, pwede naman eh. Sayang yung space. By mode 5.1 of our calculator, pagandahin lang natin natin para may variety. By mode 5.1, we're going to get values for A and a value for A and value for B. So, paano natin kukunin yan? Well, let's go to our calculator. Let's go to mode, no? So, mode here. And we need to go to 5 kasi yun yung ating equation. May equation solver na kasi siya sa built-in naman. So, gamitin natin yung tools na meron tayo. Pwede naman siya gamitin sa exam. So, 5.1, two equations, two unknowns. So, from equation 1, this equation, no? Ito, from this equation. From equation 1, kailangan natin kunin yung mga coefficients niya. For A, the coefficient is 1. For B, 1. And then, of course, yung constant part is 1. Now, we must, again, no, take note na yung form sa mode 5 ay ito. Ax plus by equals c. So, ibig sabihin, dapat nandun sa kabila yung kabilang hand side of the equation yung constant natin. In other words, in this case, for equation 1, meron tayong 1, coefficient ng A, 1, coefficient ng B, then yung constant natin which is 1. For our constant naman here, so negative 1, so equation 2 natin, we have negative 1. What else? Meron tayong, I'm sorry, hindi pala negative 1. We have 1 kasi A muna. And then negative 2. And then finally negative 1. So solving for A, we have 1/3. Sulat natin dito, 1/3. And then of course, for B, for B, we have yung 2/3. 2/3. Alright. So, pwede na natin i-substitute yan back dito sa ating partial fraction decomposition. This value of A and this value of B. So, magkakaroon tayo ng, copyhin ko na lang to for, Copying ko to for easy and faster. Yan. No? So by partial fraction decomposition, yan. Okay. Nakikita ba siya? Nakikita naman. So, plugging in yung value natin for A and B. Meron tayong A, which is 1/3. So, this will be 1/3 x minus 2 plus x plus 1, which is, that has a numerator of 2/3. So, ito na equivalent ng ating partial fraction decomposition. So, plugging it back into our equation, plugging it back, we'll have, copy ko na lang to, no? Para mas mabilis. Kakaroon tayo ng we'll have equivalent of e raised to the integral of, yan, may 3 tayo. So, if I multiply 3 to 1/3 and 2/3, magkakaroon ako ng 3 times 1/3 is 1. So, this will be dx all over x minus 2 plus 2, no? 2 integral of dx over x plus 1. Yan. So, further expanding this, we'll get mu of x to be equal to, we have u du, no, or du over u. This is ln u. So, if u is x minus 2, then du is simply dx. So, pwede na itong e raised to the integral, or e raised to ln, yan, shortcut ko na, x minus 2. X minus 2. Plus 2, ganun din to. Let u be x plus 1, so du is equal to dx. In other words, integral of du over u. And du over u is ln u. In this case, you have ln x plus 1. Okay? Yan, ln. So, by properties of logarithms, we can make this coefficient here 2, power of x plus 1. So, magkakaroon tayo, simplifying further, no? You have e raised to ln x minus 2 plus ln x plus 1 squared. Yan. Again, by properties of logarithm, ln plus ln can actually be equal to, or ln m plus lmn can actually be simplified to ln, or ln times m times ln m times n. Yeah. In other words, pwede natin silang pagsamahin. Magkakaroon tayo ng simplified expression as e raised to ln, yan, ganito, x minus 2, and then x plus 1 squared. And we know that any value, or any natural logarithm that is raised to e, will cancel out. So, finally, we have mu of x equals x minus 2 multiplied by x plus 1 and then squared. Ayan. Okay. Now that we have yung ating integrating factor, ito yung ating integrating factor, we can now proceed, excuse me, in getting our general solution. And that is mu or y mu of x equals integral of mu of x q of x dx and then plus c. Ayun. So plugging in our values, we'll get y and then our mu of x, which is x minus 2 and then x plus 1 squared equals the integral of the same mu. We have x minus 2 multiplied by x plus 1 squared multiplied by q of x. What is our q of x? That's 1 over x minus 2. Of course, dx and then plus c. Tignan ko na lang ha. Sorry. So, we will notice, no? Move ko dito ng konti. Ayan. Kaya ko naman. Yan. So we'll notice that x minus 2 cancels out here. And we are left with x plus 1 squared. So let's write that down. X plus 1 squared dx plus c. And we know that integrating this power rule, we'll get x plus 1 plus 1 raised to 3 all over 3 plus c. Okay? And of course, copying yung ating y, x minus 2, and then x plus 1 squared. Now, we can multiply, or rather divide x plus 1 squared here on the left-hand side. And makikita natin that this will be divided to x plus 1 here, a similar term. So that will be x plus 1 cubed divided by x plus 1 squared. So obviously they will cancel each other and 3 minus 2 will be equal to 1. So magkakaroon tayo ng y, an expression of y explicitly. This will be y equivalent to yan, x plus 1. Matitira pa tayo ng isa rito. All over 3. Sige, akit na lang natin para naman may space. So we have y equals x plus 1 all over 3 and then yung ating x minus 2 plus c, quantity x minus 2 multiplied by x plus 1 squared. Yan. So that's an equation that is expressive of y. Pero we're not yet done kasi we need to solve for the particular solution given that we have the condition at y is equal to 5 having x being equal to negative 1. So let's take a look at our equation, no? Taking note of this condition. Pag sinubstitute natin siya rito, kakaroon tayo ng 0 kaagad because negative 1 plus 1 is equal to 0. So mag-0 kaagad to si c, no? Hindi naman tayo pwede mag-divide ng 0 over 0, no? Kasi bawal nga siya na rule. So instead, we can use this expression, no? This one, itong nasa taas. Ganun din naman siya, equivalent, no? So let's go ahead and do that. Or actually, just manipulate this expression. Express it in terms of c muna before we execute. So we can do that. we can solve actually for the value of c here, being c equals y minus x plus 1 all over 3x minus 2. Okay, now this whole equation is multiplied by this equation here. X minus 2, x plus 1 squared. Right? So solving for c, let's copy this one. Okay. Copying this equation and pasting it here. Yeah. We can solve for c right away, right? And that is, so plugging in all our values, we have plugging in all our values, we have 5. I'm sorry. Y is equal to 5. So to 5 minus x plus 1. X is equal to negative 1, right? Negative 1 plus 1 all over 3. Negative 1 minus 2. And then multiplied by x minus 2. And then negative 1 plus 1 raised to 2. No? Simula dito pa lang, finish na, no? Finish na. Negative 1 plus 1 is obviously 0. Raised to 2 pa. So this is entirely 0. And then anything you multiply to 0 will be equivalent to 0. That's why c is equal to 0. Yan. Now that we have c, we can substitute it back to our equation, which is this equation y. Let's copy that. Let's go back here. So actually here. So for our particular solution, we have this equation here. So substituting the values, since c is equal to 0, since c is equal to 0, then therefore we are left with y equals x plus 1 all over 3x minus 2. And there we have it, ladies and gentlemen, our final answer, a particular solution, y equals x plus 1 all over 3 times x minus 2. Okay. Okay lang tayo? Okay lang? Alright. So that ends my presentation, that's my last problem number 8. I hope you enjoyed solving all those 8. Now for problem set 7, please do take note of this. 5 problems. Yan. And then please solve it sa ating school book and sa grade school. Alright. So as a silence, let us pray. I will continue, O my God, to do all my actions for the love of thee. Saint John Baptist de La Salle, pray for us. Live Jesus in our hearts forever. In the name of the Father, the Son, the Holy Spirit. Amen. Alright, so thank you guys for watching, and I hope to see you in the next lesson. Bye and God bless.